You are standing in a sun-drenched clearing, the air heavy with the scent of wild sage and ripening berries. Your fingers are stained purple, the juice tacky on your skin as you reach for a particularly plump cluster of fruit hanging just above eye level. The sun is warm on your shoulders, and for a moment, the only sound is the rhythmic buzz of a few nearby insects. This is a scene of utter, mundane tranquility. You aren't thinking about survival, you're thinking about how sweet those berries will taste once you get back to the rest of your group. You feel like the protagonist of your own life, a master of your environment. Then the wind shifts. You notice a small patch of grass about 20 feet away that isn't swaying with the rest of the meadow. It's a subtle, heavy stillness, a shadow that shouldn't be there. Why did the birds just stop singing in the trees behind you? Why does the hair on the back of your neck feel like it's being pulled by an invisible string? You aren't a person in a peaceful meadow anymore. You are a biological curiosity, a collection of soft tissues and protein being evaluated by a mind far more ancient than yours. For millions of years, this was the primary human experience. We like to imagine ourselves as the brave hunters of prehistory, but the fossil record tells a much darker, more humbling story. What animal actually killed the most ancient humans, and how did that one specific predator shape the very way your brain works today? While it's tempting to imagine a roaring lion or a massive grizzly bear as the primary architect of our ancestors' nightmares, does the size of the predator really correlate to its lethality in the deep past? If you look at the most dramatic fossils we've uncovered, you'll see the terrifying weaponry of the Mecharodontini, the true saber-toothed cats. Species like Megantereon and Dinofelis were the heavyweights of the Pliocene and Pleistocene landscapes. They had canine teeth the size of daggers, designed to pierce the thick hides of prehistoric horses or the soft underbellies of juvenile mammoths. When we find hominin remains near these predators, it's easy to assume we were their primary menu item. But if you look closer at the biomechanics of these cats, a different question emerges. Why would an animal designed to take down a 500-pound ungulate waste its energy stalking a skinny, 60-pound primate that lives in a group and carries sticks? Paleontologists like Lars Werdelin have spent decades analyzing the bite forces and dental wear of these ancient cats. What they found is that while a saber-tooth could certainly kill a human, we were likely just bycatch or a meal of last resort. We were small, we were agile, and we didn't have enough body fat to be a primary target for a massive ambush predator. So, if the most famous monsters of the Ice Age weren't hunting us systematically, who was? That sounds logical enough. But what if the most frequent killer didn't even have 4 legs, and instead attacked from a direction our ancestors almost never looked? For nearly a century, one of the most famous fossils in the world was a complete mystery. In 1924, Raymond Dart discovered the Tong child, a skull of Australopithecus africanus that dated back roughly 2.8 million years. The skull had strange, almond-shaped puncture marks in the base of the eye sockets and small scratches across the cranium. For 80 years, researchers assumed the child had been killed by a leopard or perhaps a small group of hyenas. But did a ground-based predator really leave those specific marks? In 2006, the renowned paleoanthropologist Lee Berger, along with researcher Ron Clark, decided to test a new theory by comparing the Tong child's injuries to the remains of modern monkeys killed by crowned eagles in Africa. The results were chillingly identical. The eagles would dive from the sun, making them invisible until the last second, and drive their talons directly into the eyes and brain of their prey to cause instant paralysis. They would then carry the small primates to their nests and systematically peel back the skull to get to the brain. This wasn't a one-off accident. Berger's research suggested that for millions of years, large raptors were a primary predator of juvenile hominins. This raises an even bigger question. How many of our ancestors were snatched from the ground before they even knew a predator was in the area? If the sky was a source of constant, silent death, how did that change the way we evolved to scan our environment? However, as terrifying as a shadow from above might be, does a predator that only targets the young and small really count as our greatest killer, or should we look toward the water's edge instead? Every ancient human needed to drink, and in the arid savannas of East Africa, that meant congregating at the few available rivers and lakes. But these water sources were the primary territory of Crocodilus anthropophagus, literally, the human-eating crocodile. In 2010, paleontologist Christopher Brochu identified this species at Oldaway Gorge, dating it back to about 1.84 million years ago. This wasn't a modern crocodile. It was a specialized, thick-skulled predator with horns and a bite force that could snap a hominin femur like a dry twig. Why is this significant? Because when we look at the fossil labeled OH7, the type specimen, for Homo habilis, we see something horrific. The fossil includes a foot with clear, deep serration marks that match the teeth of these ancient crocodiles. These aren't the marks of a scavenger picking at a carcass. They are the marks of an ambush at the water's edge. But here's the problem with the crocodile theory. A crocodile is a regional threat. If you stay 50 yards away from the river, the crocodile can't touch you. It was a frequent killer, yes, but it lacked the one trait a truly top human killer would need: the ability to follow us wherever we went. If the crocodile was limited by the water, what animal had the versatility to hunt us in the trees, on the plains, and even inside our caves? That might lead you to believe that a nomadic, pack-hunting predator like the hyena would take the top spot. But does a scavenger's reputation really fit the profile of a systematic human slayer? It's true that ancient hyenas, like the massive Pachycrocuda, were capable of crushing any bone in the human body. We find bone assemblages in caves where hyena activity is high, and these often include hominin remains. But taphonomic analysis, the study of how bones decay and are moved, suggests that in many of these cases, the hyenas were simply moving bodies that were already dead. They were the cleanup crew of the savannah, not the primary executioners. To find the real killer, we have to look for an animal that shares our specific habitat, our specific active hours, and our specific vulnerabilities. This brings us to the work of Bob Brain at the Swartkrans Cave in South Africa. In the 1970s, Brain analyzed a skull fragment known as SK54, belonging to a Paranthropus robustus. It featured two perfect, circular puncture marks in the back of the head. Brain took a leopard jaw and pressed the lower canines into the holes. They fit with the precision of a key in a lock. But the story gets darker. Leopards are famous for dragging their kills into trees to protect them from lions and hyenas. In the ancient South African landscape, trees were scarce, but caves with vertical shafts were common. The leopards would kill a hominin, drag the body to the edge of a cave shaft, and consume it on a ledge or in a tree growing out of the cave. The bones, including the skull of SK54, would then drop into the depths of the cave, preserved for millions of years. Was the leopard our most consistent predator because it was the only one that could follow us into our last remaining places of safety? That evidence is incredibly strong, yet it forces us to ask an uncomfortable question. If leopards were so good at hunting us, why aren't we extinct? This is the central tension of the man-the-hunted theory proposed by anthropologists Donna Hart and Robert W. Sussman. They argued that for the vast majority of our evolutionary history, humans weren't the alpha predators we see in modern movies. We were, essentially, giant squirrels. We were a medium-sized, slow-moving, relatively weak primate that provided a high-protein meal for almost every carnivore on the continent. According to Hart and Sussman's data, predation rates on modern primates can be as high as 15% of the population per year. If ancient humans faced similar pressure, our primary evolutionary driver wasn't hunting mammoths, it was avoiding being eaten. This changes everything about how we view human intelligence. Why did we develop such complex social structures? Not just to hunt, but to have more eyes watching the grass. Why did we develop bipedalism? Perhaps not just to walk long distances, but to see over the tall grass where a leopard might be crouching. But even this theory has a hole. If we were being eaten by everything, which single animal can claim the most kills? Does the fossil record, which only preserves a fraction of a percent of all lives lived, really give us the full picture? You might assume that the winner must be one of these large mammals. But what if the most lethal creature in the ancient world was something you could step on without even noticing? When researchers look at modern hunter-gatherer societies like the Hadza or the Jew/Hoansi, they find that deaths from large predators are actually quite rare. Instead, they see a massive spike in mortality from something else: venom. In many tropical environments, snake bites are a leading cause of accidental death. Anthropologist Lynn Isbell proposed the snake detection theory, which suggests that the entire structure of the primate visual system, our ability to see in high resolution and distinguish color, was evolved specifically to help us spot camouflaged snakes in the foliage. If an animal influenced the very wiring of our brains, surely it must have been a prolific killer. But snakes, like crocodiles, are reactive. They bite when stepped on or disturbed. They don't hunt humans as a primary food source. They killed millions, but they didn't stalk us. They weren't a shadow following our footsteps through the woods. To find the animal that truly dominated the death toll of ancient humans, we have to look at the one creature that had the motive, the means, and the proximity to kill us more than any other. And the answer isn't a cat, a bird, or a reptile. That sounds like a riddle, but the data becomes heartbreakingly clear when you look at the transition from the Pliocene to the Holocene. What happens when the hunted finally becomes the hunter? As humans developed fire, stone tools, and complex language, the leopards and eagles that had plagued us for millions of years began to pull back. We became too dangerous to hunt. But that didn't mean the killing stopped. It just meant the identity of the killer changed. In the site of Nadarek in Kenya, researchers discovered the remains of 27 individuals who died roughly 10,000 years ago. They weren't killed by lions or leopards. They were killed by blunt force trauma to the head and neck, and stone projectile points were found embedded in their bones. This is the Nadarek massacre, one of the earliest recorded instances of intergroup human violence. As we moved from being man the hunted to man the master, we took over the role of our own greatest predator. Anthropological studies of modern hunter-gatherers show that in many groups, violence from other humans accounts for a significantly higher percentage of adult deaths than all wild animal attacks combined. We became the only animal capable of matching our own intelligence, our own weapons, and our own social coordination. So, if you were to tally every life lost in the ancient world, the leopard may hold the record for the first 3 million years, but in the final stretch of our journey, the title of the deadliest animal on Earth was passed to us. But if we are our own worst enemy, does that mean that a natural world is finally safe, or are we just ignoring the silent predators that still live among us? We think of ourselves as the victors of an ancient war, having conquered the things that bump in the night. We live in boxes of concrete and glass, far removed from the savannas of our ancestors. But your brain doesn't know that. When you're walking through a dark parking lot and you hear a footstep behind you, your heart rate doesn't spike because of a rational fear of a modern mugger. It spikes because your amygdala is running a program that was written 2.8 million years ago in the shadow of a South African cave. It's the leopard program. It's the eagle program. We are the descendants of the primates who were the most paranoid, the most observant, and the quickest to run. We are the survivors of a multi-million-year culling. Every time you feel that sudden, unexplained jolt of fear when a shadow moves in the corner of your eye, you are experiencing a direct link to the Tong child and the victims of Swartkrans. The predators of the past didn't just kill our ancestors, they built us. They dictated the shape of our eyes, the sensitivity of our ears, and the architecture of our social bonds. We didn't just evolve around them, we evolved because of them. That realization brings us back to the most fundamental question of all. If we could go back and remove those predators from our history, would we even be human? Without the eagle, would we have our sharp, color-driven vision? Without the leopard, would we have our drive for social cohesion and group protection? Without the crocodile, would we have developed the cautious intelligence required to navigate a world full of hidden risks? The answer is almost certainly no. We are a prey species that learned how to fight back, a collection of survivors who turned our fear into the most powerful technological civilization the planet has ever seen. But that fear is a double-edged sword. The same survival instincts that kept us safe from leopards now drive us toward tribalism and conflict with our own kind. We have spent so long looking for the monster in the grass that we began to see the monster in each other. The deadliest animal isn't just a biological classification. It's a role that we stepped into the moment we became too smart to be eaten. We didn't escape the food chain, we just repositioned ourselves at a level where the only thing left to fear was our own reflection. But perhaps the most chilling part of this entire story isn't the teeth or the claws, but the sheer, clinical indifference of the ancient world. A leopard doesn't hate you. An eagle doesn't have a grudge. To them, an ancient human was just a variable in a caloric equation, a certain amount of effort for a certain amount of reward. We were a resource to be harvested. And for millions of years, the harvest was plentiful. When we look at the puncture marks in the SK-54 skull or the serrations on the OH-7 foot, we aren't looking at tragedies in the modern sense. We are looking at the mundane reality of the Pliocene. This was the background noise of human existence. Death wasn't an event, it was an environment. It was as constant as the weather and as predictable as the tides. We only find it shocking now because we've had a few thousand years of relative safety to forget where we came from. We've built a world where the idea of being eaten by an animal is a freak accident, a headline-grabbing anomaly. But in the grand timeline of our species, this current era of safety is the anomaly. The normal state of being for a human is to be looking over your shoulder, wondering which shadow is about to move. Is it possible that our modern anxiety, our constant state of low-level stress, is simply the predator alarm in our brains ringing in an empty room? We don't have eagles diving for our children, and we don't have leopards waiting in our garages. But the alarm system is still there, fully functional and looking for a target. This is why we obsess over true crime, why we watch horror movies, and why we are so easily swayed by fear-based rhetoric. We are hardwired to look for the killer because, for 99% of our history, the killer was always there. The leopard has been gone from our daily lives for a very long time, but it left its paw prints all over our DNA. It shaped our sleep cycles, our family structures, and our very souls. We are the monkey that got away, but the price of our escape is a permanent, indelible memory of what it felt like to be hunted. We didn't win the war against predators, we just moved the battlefield inside our own minds. So, the next time you find yourself in a quiet, beautiful place, and you feel that sudden, irrational urge to check behind you, don't ignore it. That isn't paranoia. That is the voice of a million ancestors who didn't check behind them, and who paid the ultimate price for that mistake. It's the legacy of the Tong child and the Paranthropus of Swartkrans speaking to you through the millisecond-fast neurons of your brain. They are telling you that the world is never as quiet as it seems. They are reminding you that the berry-stained fingers and the warm sun are a luxury, a brief intermission in a much longer, much older story of survival. The animal that killed the most ancient humans is still out there, in a way. It's in the way you scan a crowd, the way you lock your doors at night, and the way your heart hammers in your chest when you hear a twig snap in the woods. You might be the hunter now, but your blood still remembers what it was like to be the meal. Think back to those berries you were picking in that sun-drenched clearing. Think of the juice on your skin, the warmth on your back, and that one plump cluster of fruit hanging just out of reach. In that moment, you felt safe because you didn't see a lion and you didn't hear a roar. But the leopards that killed our ancestors didn't roar. They didn't announce themselves with a show of force. They were just a slight change in the grass, a shadow that moved an inch when it shouldn't have, a silence where there should have been a bird's song. That tiny physical detail, the juice on your skin, is exactly what a predator would have been focused on. They weren't looking at your face or your humanity, they were looking at the pulse in your neck and the softness of your throat. To them, you weren't a person with thoughts and dreams. You were just a specific weight of meat that needed to be dragged into a tree. The next time you reach for something beautiful and mundane, remember that the only reason you are here to do so is because your ancestors were the ones who saw the shadow before it moved. The most ancient killer of humans isn't a monster from a myth. It's the reason you have eyes that can see this video and a brain that can fear the dark. The snap of a twig in a silent forest isn't just a sound. It is the definitive, closing argument of our entire evolutionary history. You aren't standing at the top of the world. You're just the one who hasn't been caught yet. If this look into our deep, predatory past changed how you see the world, consider following this channel for more dives into the history we carry in our bones, and tell me in the comments, what's the one irrational fear you have that you now suspect might be a million-year-old survival instinct?